Okay,
Yeah. Hello.
so yeah, so today agenda is like we'll do first upgrade uh in your environment, like whatever we have done for R80.40.
Mm-hmm.
So we'll try to upgrade from R80.40 to R81.20 or R81.10,
Mm-hmm.
and then we'll try to see the VPN theory, uh, and we'll try to build a tunnel, side to side tunnel.
Okay.
And then, if we have some time, then we do some CLI stuff to check how to check the tunnels with the help of CLI command.
Nice.
And then in upcoming session, like we'll do some troubleshooting, like debug and other stuff. So if you want to do troubleshooting of tunnel, we need tunnel up, right?
Mm-hmm. Mm-hmm.
So first we need to build the tunnel, understand the like phase one, phase two,
Mm-hmm.
and then accordingly we'll in the next session we'll do some troubleshooting debugging related to VPN. Okay.
Okay.
Okay, so you can share your screen and we'll start from upgrade, like we can upgrade one box today, and same things we need to follow in the production also. There is no any big things, only things like we need to follow the company process, company change process. That is the only things we need to take care.
Got it. So, the now next step, I think you have mass control. But I think we may have to enable this into a cluster, and then once we can put, yeah, sure. Should we go ahead and put this in the cluster and then upgrade? Yeah, I think that's probably what the best.
Yes, we can do that, no problem. Okay. Also make sure like cluster should be enabled on both the gateway.
Oh, good idea. Good point. Good point. Good point.
We can do check through CLI also with the help of cpconfig command. We'll cover our cluster Excel part in separate session where we'll do some debug and troubleshooting also. But today is just upgrade purpose. So cpconfig. Yeah.
Enable.
So we have like number 6.1 enable cluster membership for this gateway.
And it's reboot.
Yeah. When you to reboot it, then it will affect. Okay, so once it will up, then we need to just install the policy. If everything is good, it will be come up like IPS schema and other stuff. If everything is correct, it should be in cluster. I think we also reboot firewall too, right?
Yeah, I did. So maybe let's see what the management. Uh, so, so if
No, check on the CLI. Yeah, CLI. On the CLI firewall too. Yeah, just yeah, yeah. Okay,
really
okay. Reboot.
important.
Now maybe yeah, reboot it. Yeah,
Oh, maybe I was waiting for the yes.
yeah, yeah.
Okay.
Correct. Now it went for the reboot.
Okay. Um, mm,
Yeah, it will take time a little bit, then it will come up.
okay. I just wasn't sure if a sync interface is enabled. Mm, yeah, it's enabled. Okay, yeah. I need to go here.
Okay, so we have okay, so we have configure HA interface.
Yeah, we should be getting one more interface. Why is that external interface not showing up? Um,
Yeah.
so it's only pulling two interface, the internal and the web. Okay, so if I go here, close OK.
Click OK, install the policy, and then we need to do some modification on the topology.
Okay, you have defined a gateway encryption domain unless, but if you do not define the address, define. Okay, so we need what is it looking?
Okay, so we have configure on encryption domain. Go on the VPN section.
VPN.
VPN, yeah, extend, yes, expand it. VPN client, expand it.
Uh,
Go on the, okay, we don't have any VPN domain option. IPsec, expand IPsec. I think we have called somewhere this IP, maybe that is the reason. So VPN advanced.
I don't think we enable VPN yet.
IPsec VPN blade is enabled.
Oh,
Yeah. Just disable it at the moment. Disable
yeah.
it. Disable.
Uh, push
Now
policy.
install the policy.
Okay. Quick question. I wonder if okay, this interface, the external. Uh, let's see. Kids push policy. Install cluster. Okay. Should be all good. Okay.
Yeah, just install on all the.
Cluster down. That's fine. And if we go to the web,
No, it is failed. Just go on the details. Why it is failed? Maybe because of interface.
oh, I see. Because this
You did
interface
not configure any IP address.
fresh, maybe.
Just configure the IP address.
Uh, okay. So it got an IP yesterday, but today how come it didn't? I think I know this one usually does. Um, this switch, I think these switches have an issue where sometimes if you have to stop and start, let's see if that helps. Okay, now let's see. Okay.
Okay, you have configured to obtain it. Okay, from DHCP, right? Okay.
Yeah. So refresh. If oops. Okay, go ahead.
Meanwhile, you can see the error, like what it is showing. Just click on the failed and go on the details, like what it is showing there.
Um,
Just expand anyone. Yeah.
press
Okay.
this.
Okay. And second one, click on the second. Yeah. This error. Okay, sharing regardless of state synchronization, cluster one must have a trusted, secure network defined. Yeah.
So
Okay.
that
Okay. We need to
so,
do some. Yeah. This is mostly related to interface. I am expecting.
yeah, so we
And once we're done, then we need to do some configuration, like
have
in case of like detect, prevent, we can configure in Facebook.
cluster, we gotta get this IP.
Yeah. Yeah.
The 37.1 and no, he's
Or
oh
we can use that one cluster. I think network type will be in sync. Okay. Try
okay,
to select network type.
yeah. Oh,
Network type. Click on network type.
network type cluster.
Cluster plus sync, right? Both should be there. I think.
Um, I was setting this up as cluster network. This is in management and this is external. So
Okay, so basically sync is also used to our cluster interface, right?
sync is used for sync. Okay, got it. Cluster. You're
No,
right.
no, cluster plus sync, cluster plus sync. Try to select cluster plus sync. Let's see what is happening. Yeah,
Okay, cluster plus sync.
yeah. And you have mentioned your IP 10, 10, 10, 10, and it is one or two.
One. So so
I
so
think you are on firewall.
this is two. This is three. We cluster IP will be one or sync IP. Okay, let's see what happens. Let's see if it takes it. If it fails. Okay. I took that one. This one. We have to change this to cluster. And this one is going to be 192.168.137.1 24 internal. Okay, got that. Now click OK. We still haven't got the DHCP. That's fine. Install. Let's see what happens.
Check like interface is like IP has been assigned or not.
Yeah, okay. And then up here. Interface. Okay, this one has two, this one has one. Okay, now we got an IP. So I think I better make this permanent IP.
Yeah,
Edit
to the static.
198. So make this 50.198. Click on that. And then go to the next one. And network interfaces 97. Edit. Make this permanent IP. And then now I go back here. The push policy push worked. And now I go here, get interfaces.
Hmm.
What is the difference between topology and without topology?
With topology, like whatever we have designed,
Oh, okay.
whatever
External.
we have mentioned, like inside, outside,
Uh,
everything.
yeah. External IP, and this is going to be, let me see, it's I have to pick a different IP. So right now it's got 97 and 98. So let's see, 99 is available. You know, 99 looks like it's available. Just checking it. Okay, 99 is available. Okay, so I go from here. 50.199. It's 24. Okay. And push policy again.
Yeah, install it.
There we go.
Okay, it was open already, right?
It was, then it just like
Okay, okay, okay.
down on its
RST.40.
own. It says it's already
Okay,
open.
I think it is already open somewhere. We need to close it. Otherwise, you need to go on the task manager and then we can end the task.
There we go. Let's see.
Not responding. Ah, it was showing not responding. There was another
Uh,
smart console. We can just end that it.
should have. Okay, so now.
And just log into any of the firewall, for example, first firewall,
Mhm.
and yeah, just do log. Yeah, database. CPH Pro state. Uh, it, it should work in I think Splice also, but Pro state.
If
Yeah.
active. By.
So both are in cluster and gateway one is active and gateway two is standby. Perfect. And check here also. Yeah. Yeah, we need to set the expert password first. No,
Oh,
set expert password. Yeah, 18.
okay,
Yeah.
so scan.
So perfect. Do one thing, just check, go on the GUI of checkpoint one or checkpoint two, and check like firewall has the internet connectivity or not.
Okay, right now it settings. Okay, yeah, I mean the policy should work because if firewall has internet connection, if this
Yeah,
can go.
yeah. Just wanted to check. So just go on the CPU section. No, no.
Okay, got it. Sorry.
Go on the firewall. Go on the firewall.
Yeah,
Firewall GUI. Firewall GUI.
firewall G. Okay, got
You
it.
already there on the Chrome. Yeah, correct.
Okay,
And
yeah,
go on the bottom. Yeah,
the
CPU section. Yeah, a status and action. A status and actions.
status and
Yeah,
action. Okay, got
yeah.
it. Okay, there is some.
And just try to zoom out.
Yeah.
Okay, okay, okay. Yeah, this
Okay.
screen I wanted. No, it is quite large, just a little bit.
Okay.
100 is fine. Yeah, yeah. So just
CPUs.
yeah,
So.
just close this cross one. Yeah.
Uh-huh.
May I take the control? Just 1 minute.
Sure.
Okay.
Yeah.
Yeah, I have already. So I was just wanted to check. I wanted to check all the packages.
Last week, I think was it last week, we made a list of things we have to
Yeah,
uh
yeah.
check. Do we have it? I think.
So it's saying like major version. How many major version? Okay, only showing name here. It
Hmm.
should it should show the packages. No problem. Here is the CLI. So CLI is there. Yeah. So we need to go on the please, and if you run this command, installer,
Install. Okay, got it.
and then verify. We hit tab. So it is at the moment there is no package to display. There is no any package is available. So I think not sure firewall has the internet connectivity or not being.
Mhm.
Okay. So we are able to reach our Google DNS. And let me check on gateway here also. Otherwise, we need to download it.
Then
It will take
install.
much time. All package. Yeah, here it is looking good. Just 1 minute.
And does it need a license?
It's saying I failed to get update from checkpoint cloud. See the CPU's event log. Maybe some reason it's saying deployment agent 2589 and it is RET.40 take 294. So it is not fetching the detail from the checkpoint update server. Okay, and that is the reason it packages is not showing here. In this case, we need to download the package manually,
Uh-huh.
and then we can upgrade our file.
Okay.
So it is not a big deal. We can do here. I think WinSCP is there, right, on this machine.
Yes. I see the icon
Okay,
of it.
okay. So download checkpoint R81.20. Fresh install and upgrade. So we are not installing fresh. So we are downloading for upgrade purpose.
Uh-huh.
So you need to take your packages should be um, .tar, not .iso.
Oh,
So it is checkpoint. If it is .iso means it is for the clean install, which is
goodness.
not recommended. Yeah. So if you want to build totally new boxes, there is no the box is not in production, then we can go for clean install. But if
Uh-huh.
you want to upgrade existing box,
Mm-hmm.
then we need to download .tar. Okay.
Mm. Okay.
So let me click on download. Yeah, download.
Do we also need to download installer? What do you call that
Yeah,
thing?
yeah, yeah, yes. Yeah. So we need to download the deployment agent. Download like this.
And this deployment agent
Okay.
is same for all work.
No, we need to download the latest deployment agent for R81, R80.40 because
Okay.
we are upgrading from R80.40 to R81.20, right?
Mm-hmm.
R80.40. R80.40. Yeah, it will show the version like it will support in how many versions. So it is going to be version R80.40,
Mm-hmm.
R80.10, R80.20. So version.
I got it. Okay.
Checkpoint service engine, guide deployment agent. So what is the latest one? Latest one is like it will show here.
Mm-hmm. Okay. Got it.
This is the recommended version. It is release date on 16 June 2025,
Mm-hmm.
and we
Report.
need to download this one. .tgz. It's showing two options for appliance with ARM architecture. We
Uh-huh.
don't have ARM architectures. I think this is a different setup,
Yeah.
and it's kind of related to automatic something. I'm also not much aware. Let's download this one. So two things are required: deployment agent and image. So it's showing here. Okay, it's saying like if you want to download it, we need to log in it.
Mm.
So we have the account, right?
I have set one up.
Okay. If not, then I will log in through my. Let me log. Okay, we need to give one-time password. Let me give it. Authenticator. No, not this one. Authenticator. Checkpoint, and it's like 876 683. So maybe now we can download it. Yeah. So this is deployment agent 2589. Can download. Not sure how internet speed is here. Oh, okay. It is taking much time.
Okay, there.
Um,
That's too slow.
so we can do one thing like meantime, meanwhile it is downloading, then we can move for some upon some concept of like
VPN,
side-to-side VPN theory part.
please,
And I
please.
think deployment agent will download very fast.
Yeah.
Maybe for image it will take time because it is 3.6 GB in size.
All right.
Okay. So meanwhile, let me share my screen and we'll try to see our some VPN part. And once it is downloaded, we can inform. Then we can continue with our upgrade.
Yeah. If
So if the speed is good, then it will take like I think 25 minutes. It's showing 5 hour, but it should not. It should be early. Because this is not your laptop, right? This is inside the
it's
RDP machine we have. That is the reasons.
maybe I can turn on the extra. There's one more interface going outside. Maybe if we enable this one, it may speed up.
Yeah, just try it.
It. Okay, now it's 4 minutes.
Deployment agent will be fast because it is only in MB inside, right? 28.4 MB.
Uh-huh.
And our checkpoint images is in 3.6 GB in size.
Okay.
Okay, so meanwhile, let me share my screen
Let me stop sharing.
and we'll, yeah.
Stop sharing.
Okay, so I think you guys have an idea like what is VPN? Just what is the simple and short definition of VPN? If anyone asks in the interview, what is VPN according to you guys, like Rahman and you, Saji?
The VPN is a tunnel which encrypts um, or encrypts the traffic, it validates the traffic, um, and so nobody in the middle can decrypt and see the files. So basically, it's end-to-end and encrypted traffic.
Yeah, it is good. You, Rahman,
Yes.
what is short definition of VPN?
Sorry, come again.
What is the definition of VPN in your
Okay.
sense? Yeah, VPN.
The we can suppose that we have two sides. One is India and another is US. So we are creating a channel through public network to communicate to each other with the secure and use resource from one side to another side.
Yeah, okay.
That is
Yeah, yeah, good. So, see, simple term, VPN is a virtual private network. So, in short, we can say like it is the private communications. It is the private communication between two sides over the public infrastructure. Means this is the public infrastructure. Internet is publicly and everyone is using, and we are also using the internet, and we have created one tunnel over the internet, and our traffic from one side to another side is getting communicated. So the simple definition of VPN is private communication over public infrastructure.
Mhm. Private
That is
communication
called VPN.
over
Yeah.
public. Yeah, that makes so much.
Yes. Yeah. Because everyone is using internet, right? And we are
Yeah.
also using, and we are just creating one separate channels and over the Yeah. So this is the simple definitions. We don't need to read much theory. I will explain like whatever is required from understanding purpose. So in VPN, um, we have two phases. Phase one and phase two. So in phase one, basically, there are some messages exchange mode, main mode and aggressive mode. So we'll mostly focus on main mode because it is mostly widely used, you can say, in the productions. Aggressive mode, almost no one is used. Aggressive mode only used inside the infra. Like if you want to build tunnel between your on premises to like we can say like both devices, your devices. If you want to build a tunnel between your devices to some remote site, some client, then we mainly use main mode. Okay. So in phase one, there are main mode, and in main mode, we have six messages exchange. Main mode 1, 2, 3, 4, 5, and 6. So what messages happen in main mode 1 and 2? That is called IKE AC negotiations. IKAC negotiation means like both client is agree with some parameter like hatching, encryption, defilement, authentications. And if both is agree, then our tunnel one, like phase one tunnel will up. Okay. I will try to show with Warsaw capture also so that you guys can have much visibility. So if you want to be expert on any protocols, just try to read the Warsaw capture. So this is my way to understand any protocols. So there is technique we call Haggle, Hagle. So in main mode 1 and 2, these things, or we can say like in IKAC negotiation, these parameters change, exchange between both the peers. H means hashing, A means authentications, like for authentication, what we are using like pre-shared key or certificate. G means we have the DeFi element, and L4 we have like lifetime. Okay, let me just stop this. Maybe I think because of CPU, my pen is not working. But yeah,
If you are setting both side one of lifetime key, one side will be 8 hour, another side is 1 hour. So on that scenario, tunnel one will come up.
yeah. Just I'm coming to you. Just a minute. Let me take the pen. Here it will be good to explain. And then we'll try to see some cryptography parameters like what is encryption, what is hashing. Epic. Yeah. So we have the parameters called naming like Haggle. So H means hatching. It is just for the remember person. A for authentications. H for sorry G for defilement. Defilement is for the key exchange. And with the help of defilement key exchange, both party create share secret key, and that key basically used for encryption and decryptions. L for lifetime, like for how many times tunnel should be up, and E for encryptions,
Encryption.
like whatever our plain text, whatever data is getting, it is going to be convert from ciphertext, plain text to ciphertext, the some unstable format. So that is the work of encryptions. Okay. So in main mode 1 and main mode 2, IKE SA negotiation happen. IKE SA negotiation happen between both the side. Okay, like in hatching, I'm using, for example, SAR-256, AES-256 in encryption, DEF element 12 or 20, whatever the group we have. For authentication, we are using pre-shared key. Lifetime, you are using, for example, 26800. Okay. After that, then we have main mode 3 and 4. Main mode 3 and main mode 4. I'm explaining these are the part of page 1. It is the part of page 1 main mode. Okay. So main mode 3 DeFi element, 3 and 4 DeFi element key exchange. So with the help of DeFi element key, both parties generally create share secret key, and that key basically used for the encryption and decryptions. Key, if you enable the PFS in phase 2, so key will be generated 2 times, one in phase 1 and another phase 2. If you want to be more encrypted or infra in case of side-to-side VPN, then we need to enable PFS. So PFS is optional; it is not mandatory to enable every time. But yes, some company need good, we can say like security. And then we have like message, we can say like 5, and we have message 6 for authentication purpose. Okay, so this is about phase 1. So once these part are negotiate to each other, our phase 1 tunnel will be up.
In message number 3, the net T and net D also happen on that.
Yeah, I will
message.
show the PK file also, like how many things it is exchanged, so it will give more clarity to you. Let me just erase this. In phase 2, we have like quick mode. We have like quick mode. And in quick mode, basically 3 messages exchanged and all are encrypted. So basically, if anyone asks, we can tell like phase 1 is just a secure channel. Secure channel, or someone call it tunnel. So phase 1 is just a secure channel or tunnel. With the help of phase 1, our actual data get transported in phase 2. Actual data. Sometimes question asked in the interview, like if phase 1 is down, still our data will it will impact on any traffic? It will impact on any data traffic? No, because till lifetime, everything is handled, because uh, packet is handled by phase 2, not phase 1. Phase 1 is just for the secure tunnel. With the help of phase 1, phase 2 is built. Actual data transfer under phase 2.
And all data will be transferred as a secure in phase 2.
Yeah, in phase 2, we have also some negotiation like encryption, hashing, DH, and that is called PFS. So if you enable PFS, that is, what is the definition of PFS? If anyone asks in the interview also, perfect forward secrecy means additional DeFi element exchange. Additional DeFi element exchange happen in phase 2, that is called PFS. It is optional. So if you enable PFS, two share secret key will be generated. First in phase 1 and second in phase 2. Both are different. So for example, if attacker get compromised the key in phase 1 key, still they can't access our details, or they can't you know uh, do some modification in our actual data, because phase 2 share secret key is different, because in phase 2 also DeFi element exchange with the help of PFS. Okay, so this is about phase 1 and phase 2 in main mode. Okay, one important thing in side-to-side VPN, guys, it is provides CIA. CIA. C means confidentiality. Confidentiality means, I think everyone aware. I think you guys also know what is confidential. Confidentiality means whatever things I'm sharing with the genuine guy, not any third party and other stuffs. Whatever communication I'm doing with the actual and genuine guy. That is called confidentiality. Integrity means whatever data we are exchanging between both peer, there is no any modification in the middle. So IPsec provide this, that is, we can say like integrity, that is called hashing. And then we have the aim is authentication, means whatever things you are exchanging, we are first authenticating. Like okay, we are agree with okay, both sides are using pre-shared key. I am using 123, you are also using 123. So both side has agreed. And if both are agree, okay, authentication has been clear. Okay, we are communicating with the genuine guy because we have authenticated successfully with the same password, whatever set from our side and your side. So that is called authentication. This is not accessed by any third party. So CIA, confidentiality, integrity, authentication, or maybe say someone called availability, it provided in by IPsec. Okay. So this is about the phase one, phase two, little bit overview, like what happened in phase one, phase two, and what is CIA and how IPsec provides CIA, what is VPN. So these types of questions generally asked in interview also, and these types of question is important to understand before building tunnels. This is not completed. We have so many things in IPsec. Let me show some little bit about cryptography also, like so that you guys get got some little bit much idea, because at the backend our image is downloading, so we have sufficient time. So for examples, we are using in encryption, we have like symmetric algorithms and asymmetric algorithms. So what is symmetric algorithm? Mostly you use symmetric algorithms. So what is symmetric algorithm? Symmetric algorithm means, for examples, anything we are sending from here. For example, this is our data 1, 2, 3. So with the help of encryption, for example, AES, 1, 2, 3 is going to be converted with some random, dummy kinds of word. For example, a star, something, this is ununderstandable, we can say. So if you are converting plain text to ciphertext, that is called encryptions. In case of symmetric encryptions, we use same key. For example, this is 1, 2, 3 key. This key is used for encryption as well as decryption both. But in case of asymmetric, encryption key, for example, 1, 2, 3, and decryption key, for example, 2, 3, 2, 1. So encryption and decryption, both keys different in case of asymmetric. An example of asymmetric RSA, basically used for the, that is the part of asymmetric algorithms, basically used for the key exchange. And in case of symmetric algorithms, we have the example like AES 1 to like 256 or latest one. Okay. So this is about the symmetric algorithm, asymmetric algorithms, and cryptography is play a vital role in IPsec. In short, I can tell configuring IPsec tunnels, it's only 10 to 15 minutes, 5 minutes work. But before configuring tunnel, we need to understand the process, what happened in the backend. So if you want to understand that process, we need to know cryptography, like symmetric algorithm, asymmetric algorithms, what is hashing. Okay. So encryption, like we are converting plain text to any ciphertext. Ciphertext, like it is ununderstandable language, that is called encryption. Decryption means same thing. We are decrypting ciphertext with the help of key, and it is converting plain text. So that is called decryption, and this is encryption. For example, here it is mentioned, if it is mentioned like Ahmad, and this is the plain text, and it is converting the ciphertext. So this is how encryption like AES 256 works in the backend. So now it is pretty much clear for you guys why use AES 256, why we select in phase one, phase two. If anyone asks in the interview, we can directly tell at the end the answer, right?
Yeah.
Okay, one more thing we have like I just mentioned like symmetric, asymmetric. So in symmetric, we have same key used for encryption, decryption, and the example of symmetric is we have AES. Let nowadays it is I think AES 256 is the latest one, and nowadays it is mostly widely used symmetric algorithm. This, not this one, DES, 3DS. These are the old one, but latest one is like AES 256. So it has more capability. We can say like bits. So for example, whatever data we have, it is going to be converted in so many we can say like bytes or in word in unstable format. Okay, and the asymmetric, in asymmetric we have different key used for encryption, decryption. So we just need to know that part only. And one more thing, let me just, yeah, hashing. So understanding VPN, we should aware about hashing, encryption, like AES, hashing like SHA-256, DH, what is the working of hashing, what is the working of DH, what is the working of encryptions. So now we know what is the working of encryptions. Now we need to see what is the working of hashing. So hashing basically is provide to integrity of the data. Like there is no any modification in the middle. For example, this is our data. For example, 1, 2, 3, and this is from one side, like peer one. And while sending to the peers two, it should some algorithm, and both has been agree in our phase one. For example, SHA-256. So it is going to be use this data plus hatching algorithm, and it create some hash messages. For example, maybe YJDX, for example. If this data received to the peer, it is going to be keep the data separate, and it's use your on hatching method. For example, because both has been agree, like we are using SHA-256, it is only going to calculate at their side, and it will generate its one hashing value, like for example YZX. If both hashing, we can say message is same, then peer can understand, okay, there is no any modification in the data, and this is the genuine data. So this is how hashing work in the middle in case of IPsec BP. Okay, so this is the plain text, and it's using hashing algorithm, and it's convert this to the hash text. And in hashing nowadays we are using not MD5. MD5 is very old. We are using like SAP 5.2. So mostly company using SAP 5.2 in side-to-side VPN. Okay, so this is about hashing. And then we have last one like Diffie-Hellman. So Diffie-Hellman is just understand like it is, there are so many mechanisms in the backend related to Diffie-Hellman. There are some mechanism formula is there, like how Diffie-Hellman key exchange in between both peers. So that is the totally different things. But just for understanding purpose, Diffie-Hellman basically used to exchange the key, and with the help of key exchange, both generate share secret key, and that share secret key used for encryption and decryption. For example, here let's try to understand a little bit here. So what is the formula here? Okay, secret key. So calculating secret key formula is, I think this is the formula. B to the power A mod P. Mod means kinds of reminder, right? So maybe in this example, he has, it is considered some little bit, we can say like he consider A is 11 power 16 mod 23. It's considered some random number. So with the help of this formula, and it will let remove, yeah, here it will clear it. Yeah, so while communication between both the peer, private key generally not share, right? Private key generally not share on the internet, basically we can say, right? I think you guys also aware. So in this example, he has taken some random number P means prime number, which is not divisible by 2, and G means generator 6. And this is the private key 5 from this side, and this side, for example, this is the peer 1, this is the peer 2, and it's considered private key 5, and here private key 4, and then randomly generated private key both side. We'll see in the Wireshark, so it will give more clarity. And how to calculate public key? This is the formula, like G to the power private mod P, and G generator, and mode means reminder, P means prime number. So these are the some mathematical calculation happen, and with the help of this formula, it's create public key here 2, here public key 9, and both public key basically get exchanged while doing our negotiations. Private key generally not exchange, but public key generally get exchanged through peer. And once public key, for example, peer 1 public key received to peer 2, and peer 2 public key received to peer 1. And with the help of this, J generated share secret key. So peer 1 using peer 2 public key and its private key and some mechanism to generate share secret key. Peer 2 using peer 1 public key in its own private key and some other mechanisms to generate share secret key, and both keys is same. Once we do the calculation, calculating the share security, so this is the formula: shared public key, power private key, and then mod P. P means prime numbers. So whatever we have considered prime number, for example, let's consider here, it is considered here 13. So once both sides done the calculation, share secret key generate 3 here, 3 here. And this key is used for encryption and decryption. And that key is not shareable on the internet while communications. Only public key is exchanged in between the peer negotiations. So this is some mathematical calculations related to Diffie-Hellman. So this is how Diffie-Hellman play a vital role in side-to-side VPN or in cryptography while exchanging the key. So now I hope little bit you guys have idea about Diffie-Hellman, right?
Mm-hmm.
Do you have any question? Then we'll continue.
No, I think I'm good. I have to review.
Okay, I'm looking.
Yeah, we just need to. No one asks these types of question in interview. I'm just explaining for you guys understanding like how it is, how IPsec is secure, because we are communicating over the internet, and how it is secure. So because these are the mechanism happen in the backend. So these things happen in the backend. That is the reason IPsec secure. Otherwise, configuring IPsec is only 10-15 minutes work. We need to understand the mechanism what is happening in the backend. So we only need to be aware about the formula to calculate the public key. We just need to remember this formula and calculate share secret key. This is the formula. That's it. And in this case, it is only consider P as a prime number, G as a generator. Generator we know very well, kinds of reminder. And here it is considered any random private key, for example, 5 here 4, and then calculate the share secret key. And both side it is same. So we just need to remember the formula for calculating public key and share secret key, and only public key is exchanged between both the side, not other parameters. Let me show here. It will give more clarity. So IPsec, IJEC, check MP, CloudShark. Yeah, so this is very good site, CloudShark. We don't need to do any capture and all. It will be a predefined or pre-capture packet is already there, and we can do review for any protocol like TCP, UDP, DNAs, IPsec. So we are using main mode IKEY version 1, and IKEY version 1 main mode we have 6 messages exchanging phase 1, made 1, 2, 3, 4, 5, 6, and 3 message exchange in phase 2, right? So if you see in first messages, how many things get exchanged? So this is a good way to understand any protocol. So if you see here, like IJCAMP is basically Internet Security Association and Key Management Protocol. It is responsible. It is a protocol which is responsible for IPsec. We can say like IPsec tunnels. So They need to be aware about these protocols. So what is the first message? Initiator SPI is SPI sorry SPI security parameter index. So basically SPI created with some random number, some a random number IP address, and it's creates some SPI, and it is going to be hashed and it is going to be shared to the peer. So in first message, initiator SPI, then we have the flags. I think no one is aware about the flag, but yes, in IPsec we have flag also. So if anyone asks in the interview in depth level, we can tell. In IPsec we use flag, yes. How many types of flag? 3. This is the encryption, commit, and authentications. So this is the first packet. That is the reason here it is not showing any authentication now. So in first message, like main mode 1, initiator or like from source side SPI. Then we have flags. There is no any flag. Then we have payload. And in payload we have seen like proposals. And then we have payload transform. See, so how many these types of IKS negotiation happen from source side, peer 1. It is saying, okay, in hashing, I'm using SHA. In group, I'm using 10 to 4 bit. That's a def element group. For authentication, I'm using pre-shared key. This is my for lifetime second. This is my using duration 86400 in seconds. So lifetime type is seconds, and in second it is using this is the time. So these messages sent by a source peer 1 to peer 2. Okay, there are so many things. It is also like Rahman asked like about night reversals. So it is everything is there. Next payload is vendor payload lane 28, and so these many things sent from source, that is peer 1 to peer 2 in IKSA negotiation. If you see the message number 2, it is going to be agree with some payload proposal. If we click here, yeah. So whatever sent from peer 1, it is going to be agree with that. Okay, let's use same thing from outside also. And so that is IKSA negotiation happen. If you come to the message number 3, main mode 3 message number. This is the message number 1, 2, and this is the 3. Here key generally def element key exchange. See. So let me show here. Somewhere we can see length also. Yeah, payload is key exchange. And this is nonce data. And if we just open it, and this is the hashing of the address. It is going to be hash of it is going to be hashing of the address. And I want to show the key also. Just okay. Yeah, so this is the key exchange data. So whatever the key, maybe this is the public key, but it is not kinds of plain text. It is in hashing format. So via this communication, both will be received publicly to each other. Like peer 1 will receive the public key to peer 2, peer 2 will receive from to the public key of peer 1. So with the help of public key and some random numbers, private key has at both sides they generate share secret key, and that share secret key basically used for encryption and decryption. So this is how a mechanism happen in the backend. Okay. So this is the message number 3. So 3, 4 for the key exchange, and then 5 and 6 for the authentication purpose. If you see, so now in 5 and 6 message will be encrypted. So in interview also, if anyone asks, we can tell only message number 1, 2, 3, 4 is going to be sent in plain text. Message number 5 and 6 is generally get encrypted. Okay. So this is about phase 1 main mode, 6 messages, and all the message in phase 2, that is quick mode, it is basically encrypted. See, encrypted data, and initiator for our source, Then this is the SPI for the responder. This is peer and exchange type quick mode. Flags, it is set encrypted. Yeah, see here. Encryption flag is set here because this is the message number 1 in quick mode, phase 2. And length of data 220, encrypted data 192 bytes. So while doing troubleshootings, if some data get lost through IPsec VPN, then we need to do if you do analysis on Wireshark, then we can compare, okay, this is the length of 220 and how much you receive on the firewall side. So if you do debug, all the things will show there. So it will generally take much time, little bit. We need to give some work. We need to do some work in the backend to understand this. It took basically much time for me also to understand all the packets and all. And this is the message number 2 in phase 2 that is also encrypted. Length 220 and encrypted data 192 bytes. And this is the third message. So this is how negotiation happened between peer 1 and peer 2 in IP6. So I hope it is clear and no one asked question, in the interview. If you study like this, it is enough to troubleshoot. It is enough to give answer. It is enough to implement in the lab.
That's good.
Okay, and one more thing, like someone asked sometimes, what is the difference between like IK1, IK1 version 1, like IK version 1 and version 2. So there's some point like we need to consider like, for example, IK version 1 and version 2. Sometimes maybe they ask, or maybe we need to configure, sometimes we need to configure version 2, not version 1 in our production. So the things in like it, version 2 little bit faster because all the 4 messages exchange in one go. Like for example, we have main mode 1, 2, 3, 4, 5, and 6. So for example, 1, 3, and 6 get exchange in one time. 2, 4. Okay, I think we are wrong. 1, 3, and 5 get exchange in one time. 2, 4, 6 get exchange in one time. So that is the reasons it is faster. So whatever process happen in the back end, it is kind of fast in case of version 2 because 3 messages exchange at one time. Second important things in version 1, version 2 is like in version 1, for example, for authentication, we are using, for example, pre-shared key, for example, 1, 2, 3. In case of version 2, we can use different authentication. For example, peer 1 using like, for example, 1, 2, 3, or maybe pre-shared key, and the other side we can use different also. That is acceptable in version 2, but not version 1. Second things, this is the first difference, this is the second, and third one is very, very important. Let me erase this. So if you give 2, 3 points in the interview, that is fine. Third is like lifetime. For example, in peer 1, we are using lifetime 200, just for example, 200 seconds. If you're using version 2, in peer 2, we can use lifetime different also. That is also acceptable. Lifetime is just for like for how much time tunnel should be up. So these are the some little bit difference in phase 1, version 1 and version 2. So if anyone asks, we can tell like this in the interview.
If phase 1, we can set different lifetime key on that scenario, that will be establish the tunnel.
In version 2, but not version 1. Version 1 should be common for both sides.
Okay, same lifetime key for both sides.
Yeah.
Okay.
And if you are using version 2, it will acceptable.
Okay. So what is the use of lifetime key? If we are set 1 hour lifetime key, then after 1 hour, what will be negotiation will be happen?
Yeah, so lifetime is just for like till lifetime tunnel will be up, and once lifetime has been expired, after that it is going to renegotiate all the parameters again. Why it is
Okay.
important? For example, if someone get compromised some things, so after that, if it's going to be renegotiate, it is going to be generate some different share secret key, whatever I have shown with the help of Diffie-Hellman. Okay, so for example, if someone get compromised the key, for example, our share secret key is 3 and it's get compromised. So it is going to be again renegotiate and generate some another share secret key, and that will be not with attacker. So that is the reason lifetime is important to renegotiate our all the parameters in between
Okay.
phase one, sorry, in peer one and peer two. Okay.
In live production, we can see DPD timeout. So why we are getting such type of error? Suppose that
Which
we have
timeout?
created tunnel between Prisma to
Okay,
AWS,
okay,
but
okay,
I
okay.
have tunnel between
DPD is
them
just
and
for the
some.
monitoring purpose. Like, are you there? Are you there? Kinds of keep aliving purpose. Just using for some time now. DPD sometimes configure in the production to keep our tunnel always up. Okay. So if here I'm telling to you, are you there? Are you there? Are you there? If there is no any reply, it will put a down or maybe you get alerts from the mail or whatever the monitoring tools configure in your company. Okay. If you do here, let me. It is just for it is the dead peer detections. It just used to be monitor our peers. Like, are you there? Are you there? Are you there? So it depends upon our business need, goal. Like you want to be monitor our tunnel every time. Tunnel should be up every time. For example, if you're working with service-based company, you are providing services to the customer, and that is happening through our data gate exchange with the help of side-to-side VPN tunnels. So at that times, our tunnel should be up every times. For example, if you're working on product-based company, we are working for our client, our team, our we can say like our company employee only. We are not providing any services. At that times, maybe we can't do dead peer detections. Now I hope now it is clear for you, right, Ramanji?
Yes, yes.
Yeah. So if a peer does not respond with the configure timeout, the tunnel is considered down. So this is the work of DPD.
Just like a heartbeat message, they are exchanging
Yeah,
between
yeah,
them.
yeah,
Heartbeat keep alive.
yeah. Correct. See, in short, in short, let me just summarize a little bit. IPsec we use provide secure connectivity over public infrastructure. There are two phases, phase one, phase two. In phase one, 6 messages exchange. In phase two, 3 message exchange. And for exchanging all the things, we have some cryptography used like hashing, Diffie-Hellman, encryption, decryptions. With the help of that, both peers generate share secret key. That key is used for encryption and decryptions. That's it. That's it about the VPN. Okay. And now we need to understand from checkpoint perspective, there are some terminology we need to understand. Okay. So we have covered the side-to-side VPN theory part. We have also seen how many message exchange, how many things happens with help of PK file by in Warsaw. So don't, if anyone asks, just go with this CloudSark, and if you read this file, we can say like one by one, like hop by hop. It is fine to troubleshoot, debug everything. In checkpoint, we have some terminology we need to understand, like VPN domain. What is VPN domain? You guys have a little bit idea about VPN domain?
Mm, It's it's the subnets behind uh, the VPN firewall.
Yeah,
Oh,
correct. So VPN domain is basically our encryption domain, like which traffic you want to be sent through tunnel. That generally defined in VPN domain. That is our interesting traffic. Someone call interesting traffic. Someone call encryption domain. For example, in our lab topology here, Yeah. So in case of our lab topology, so you want like 192.168.1 dot for example 1.0/24. So this is our site 1 subnet. You want like 1.0 subnet should communicate towards 2.0 subnet. So this is our VPN. This is our VPN domain. This is the encryption domain. So we need to define these things in encryption domain. This is called interesting traffic. So only this traffic will go via tunnel. Same for this side. 2.0 will going to be communicated with 1.0 network. So that is only going to through tunnel. Rest traffic will go as it is over the internet. For that, we need to add separate rule. We need to do netting here. And what we'll do, we'll disable the NAT for IPsec. We can select traffic. So for example, if you want to communicate from 192.168.1.10 to 192.168.2.10, so that traffic should not be netted. That traffic should go only via tunnel. So we can disable the NAT inside the VPN community. So while doing that, this traffic only go via tunnel and it is not going to be out to the internet. And for rest traffic, for example, maybe we have some another here, people like 10, 20 people in LAN side, maybe DMZ, and that traffic should not go to the VPN. So only, required traffic should go via VPN, not all the traffic. So for remaining traffic will go as it is to the internet, and only required traffic will go via tunnels. This is called our VPN domain. That is called encryption domain. Okay. In VPN domain, we define same things. Then we have community, VPN community. Like in Checkpoint, we have a star and then mesh. Okay. So we have a star community and mesh community. So I think you guys already aware from name. A star means like hub and a spoke kinds of things. So this is our hub, and so many we can say like a spoke, maybe another site, a tunnel with our hub. That is called a star topology. In case of mesh, it will look like this. This is the star topology. This is our hub, and other side gateway is made tunnel to our hub only, not each other's, not each other. But in case of mesh, not like hub, everyone make tunnel to each other's. But in case of a star, it is hub spoke. For example, site 1 firewall will tunnel with hub, site 2 with hub, site 3 with hub. But in case of mesh, site 1 with site 2, site 1 with site 3, site 3 with site 1, site 2. Everyone is connected to each other with site to site tunnels. Means every gateway is built tunnel to each other. That is called mesh. So we need to define, we need to configure VPN community object as per our business need. Like which types of topology we want to achieve in the company. Okay. Accordingly, we need to take. For example, we have one customer like and they want to use our service in the company. Maybe we have application server hosted in our DMZ and they want to access through site to site VPN. So we can create tunnel like mesh topology, like our gateway to their gateway, not kinds of hub and a spoke. So both things generally change. It depends upon our requirement in the company. Okay. So this is the VPN community, VPN domains. These are the terminology generally used while configuring the tunnel site to site VPN. Then you know types of tunnels. It is also very widely asked in the interview, route based and policy based. So Palo Alto is fully route based. Checkpoint is security, we can say a policy based tunnel. Now also supporting route based, but mostly it is for policy based. Means we need to define source and destinations in security policy and then call these to the VPN community in the policy itself. But in case of Palo Alto, we need to define, we need to provide route, we need to add route towards tunnel. Like for example, if you want to communicate from source, for example, if you want to communicate to 192.168.1.0, please send this traffic to tunnel 1. So we need to define route on Palo Alto, but in case of Checkpoint, for example, if you want to communicate, this is the source 1.10, and if you want to communicate with 2.10, please send this traffic to this community, whatever we have created on the Checkpoint. So this is the type of tunnels, route based and policy based. Then there is option like encrypted traffic. So once we do our tunnels, once we try to configure the tunnel, there is option like encrypted traffic. So once we click check mark, all the traffic behind our gateway, it is going to be sent to the tunnels. This is not recommended. So never click that option. Once we click it, every traffic behind our gateway is going to be sent towards the tunnel. So it is not recommended. We only send the traffic which is required. Okay. Then we have tunnel management, like how we want to keep, like one tunnel per subnet pair, or we'll see the option. Okay. So this is some terminology in Checkpoint while configuring side-to-side VPN. So let me know if you guys have any questions.
About concepts. Okay. Now, lab and troubleshooting is the key.
Yeah. Main troubleshooting. This is the concept. Mostly, as per my experience, when I face challenges in side-to-side, mostly if you are using iKey version 1, we face in pre-shared key. Our phase 1 tunnel generally down because of mismatch pre-shared key or mismatch encryption domain in phase 2. So basically, if encryption domain is wrong, for example, we did instead of 1.0/24, we mentioned 2.0/3.0. Here is also wrong. So tunnel will never come up. So pre-shared key for authentication, encryption domain, they generally create issue in the production. Also, one more thing, our communication should be reachable. Like this is the peer 1 IP, this is the peer 2 IP. So both should be reachable to each other. Otherwise, our tunnel will be not up. So these are the important steps we need to consider while building tunnels. While troubleshooting, yes, debug is very simple. So sometimes we can also analyze the debug. Sometimes we take help from vendor because debug part maybe we can also sometimes stuck because of issue. But yes, 80%, 90% work we need to do by yourself, and then take someone on the call from vendor, and we can do some rest of the work. Okay. So this is about the VPN theory and some terminology in Checkpoint. So I hope you guys understand. And once you do the lab, it will give more clarity.
Okay.
So what about Saji? Like image has been downloaded or it is still going on?
Yeah, let me check. The image is still downloading. Only the deployment is done, but the other part is a long way.
Yeah, it will take much time.
It might take this time.
Okay, no problem. We have like 30 minutes, so let me try. It will take much resources. Maybe it will success or not success. Otherwise, you have built similar types of lab topology.
Or a VPN?
Yes.
Mm, yeah, but my understanding is very poor. Also, I need to build and slowly
Okay.
understand.
Okay.
Maybe next week when we have a session,
Yeah.
maybe I'm
Yeah. Yeah.
we will have everything set up, but I won't have the configuration. Well, I'll try. I'll go through the video, understand the basics.
Yeah. Yeah. Maybe I will need to after some maybe next month I will try to increase 8 GB RAM. Okay. So once I will increase 8 GB RAM, it is perfect fine to run 2 gateway and 1 SMS.
Uh,
So for example, we have given 8 GB to this SMS, 6
uh-huh.
GB, 6 GB to both of gateway. So how much it is? Around 20 GB, right? And some GB to these devices. So almost it is 22, 23, and our RAM is 24, right? Total.
Uh-huh.
So that is the reason, it consume and it's great slowness. But let's try. If it is not successful, then we'll do in your lab. Yeah, so configuration tunnel is very simple. Only need to be take care about the theory part, like how IPsec work in the backend.
Mhm.
And meanwhile, we can see like VPN, debug, checkpoint.
I think what I did was I turned off one interface and enabled only one, and it finished. It's almost done. Like, so we're good now.
Okay, so image has been installed.
Yeah, downloaded. Yes.
Okay. Let me then stop it and we'll cover later in upcoming sessions. We need to just build similar type of topology like whatever I have, and then we'll take the control and we'll configure side to side VPN tunnels. And once configured, then we'll do testing. Like we'll try to communicate with each other with the help of tunnels. And after that, then we'll do some troubleshooting like debug and other stuff. Okay.
Okay. So
Now we
okay.
can share your screen.
Okay. See it.
Yes, we can
Yeah,
see your
yeah,
screen.
Okay.
yeah.
So
Okay, so I think it's in install.
downloaded.
Yeah, correct. 1
Okay.
minute ago. Perfect.
So
Just give
now
me the control. Yeah.
I just need to turn off one interface because I turned off one interface. Let's see if I can.
Okay. Just turn it on.
Try and get to the bottom of the screen. So I can see if I can change the view. Okay, that's good. There you go.
Okay, so
And
do by yourself, no problem. So just log in your firewall one with help of WinSCP.
okay. Disable this. Enable this. Okay, we're good. Now in SCP.
Yeah.
And we log into
Firewall one IP address.
okay.
First try to copy this. We need to copy this deployment agent,
Uh-huh.
uh, uh,
Okay.
deployment agent and image to both the firewall.
Oh, okay, I see. So we have to, so this is the deployment agent and
Yeah, so first try to log in your firewall through WinSCP.
okay.
Yeah. Firewall one and then firewall two.
7 dot. Okay. All right. Okay, this is the clish chain, I think.
Yeah, we need to change it. So just log in your firewall in export mode. Go on the export mode.
Okay.
And run the command change cell dash s
Mhm.
a space slash bin slash bash a space admin. So by default, yeah, now cell has been changed from admin. So by default, cell is not for admin. We need to change to admin.
Okay.
Yeah, perfect. Now try it.
And then usually where do we put it in? There's a temp folder or anywhere?
No, just home admin. Put in home admin.
Home admin.
Just
Okay.
go on /home/admin.
Okay. So slash home admin. Just put in here.
Yeah.
Agent.
Deployment agent and then image.
And
No, this is the jump box. Image is on the top.
oh, okay. Deployment agent we don't need.
Yeah, we have done, right? Deployment agent copying.
Uh-huh.
After that, we need to copy the image. First
Yeah.
one.
Yeah.
So upgrade basically take much time. In lab environment, at least we can consider maybe we just need to be follow the process and a step,
Mhm.
and maybe we can continue in the backend also. So what we'll do, because according to my experience in environment, one box take 30 minutes.
Yeah, I think
Okay, yeah, and one box 30 minutes. So after that, we need to do some failover and install the policy.
what I'll do is I'll maybe
Yeah, once we'll try to do one upgrade and then we'll try to fail over and then install the policy and then do the another box.
I may not have enough time. I only have maybe 5 more minutes today. Um, can we
Okay, no problem.
reschedule? Mm, maybe we can have one more class. Um, I'm available tomorrow. No. Today, what? How long will you be around? I may have my next call is only for 1 hour, I think. After that, I'll be free.
Okay, no problem. So just copy both the image and firewall and maybe before weekend in our this week,
Yeah,
we can connect some another day for at least 1.5 an hour.
yeah, that would be.
And during that, we can finish our upgrade.
Yeah, that would be.
And then when weekend, we can cover our side-to-side VPN. Building tunnel and troubleshooting.
So I think last week, like I'll go into each of the firewall, copy, make a what do you call backup,
Yeah,
backup the firewall. There's 5 steps or 6 steps. I think it
yeah.
was the last.
Yeah, we just need to take the backup, like so configuration backup, snapshot backup. Two
Huh?
backup is important,
Huh?
and after that we can start the upgrade.
Okay.
Yeah. So maybe also like once Raman ji is also available, and we'll try to connect in this week for 1.5, like 1.5 an hour, and during that we can finish our upgrade. And on weekend we can continue with our
Um,
side-to-side tunnel building and troubleshooting.
yeah,
And then we cover our secure Excel, core Excel, cluster Excels,
yeah,
troubleshooting.
that sounds good. So
Very, very important part is in checkpoint is core Excel, secure Excel, cluster Excels.
okay, yeah,
Okay. Side-to-side VPN, not every company use side-to-side VPN. Okay. Maybe some company not use side-to-side VPN. Maybe
uh,
sometime not required. But yeah, core Excel, secure Excel, cluster Excel, it is every times and it is the core features of checkpoint.
okay. So
Yeah.
yeah, the 3 things. 1 second. Oh, Core Excel. That's the CPU. Uh,
Yeah.
so
So next weekend on Saturday, we'll cover side-to-side VPN tunnel. We'll try to build it,
uh-huh.
make the tunnel up,
Mhm.
and then do some testing and we'll do troubleshooting.
Okay.
So this is about Saturday.
Okay.
On Sunday, we'll cover secure Excel, core Excel, and cluster Excel theory.
Okay.
Cluster Excel we have already built here, right, in
Yeah.
R8.14.
Yeah.
So it is very easy to we'll just follow troubleshoot part.
Okay. Got it.
So core Excel, secure Excel, and cluster Excel. So cluster Excel we have already built. We just need to do some little bit theory
Uh-huh.
and then troubleshooting.
Got it.
So that is the part of Sunday.
Okay.
And before that, we can connect like 1.5 an hour and like on any day, and then we can do finish our upgrade.
Okay.
So this is the plan for our upcoming week and weekend.
Okay.
And after that, it's up to you, like guys, like which other topics you want to cover related to daemon, like some communication issue between security gateway, SMS, how traffic flow happen. Sorry, how policy install happen when try to install on SMS and how it is go to the security gateway. We'll see these things after that.
Okay. The notes for the upgrade, I don't know, maybe I'm looking to the
Yeah,
just
it
in
was on the I think second
right?
session,
Google. Okay. Second session. Okay, I'm going there.
or maybe I have already shared it. General troubleshooting. Let me show. I think I have shared that note in Notepad document. Let me see.
Yeah, see, general shooting, I have this one, general one. But this one doesn't have.
Yeah, it is in general. It is in general. It is in general troubleshooting node. If you go on the bottom, it will show the step, all the step.
Troubleshoot. It's
Let me
just
paste it in the chat.
yeah. Okay. Transparent article. Copy. And
Because if you're giving tier 3 interview, like SME level of interview, mostly they ask maybe this is for Rahmanji, because I think Saji is not giving an interview because you handle by your own company. But just for Rahmanji, if you're giving like tier 3 level of interview, level 3 interview, so in
Yes,
checkpoint, they start packet flow, like low level packet flow, and cluster Excel troubleshooting, core Excel, secure Excel. What is core Excel? What is secure Excel? Why use both? Then little bit about if they are using tunnel, then they will come to the tunnels, like what is phase one, phase two, how many messages exchange in phase one, phase two, what is the difference between version one, version two. Okay, these
yes.
types of questions they ask. But yes, everyone can ask secure Excel, core Excel, cluster Excels, and debug a step, like how we can debug the VPN, and which daemon is responsible for VPN, VPN-D, and how we can debug IPsec tunnel related issue. So these are the important questions. Once we give this answer, definitely no one can stop to select for the selection. This is my experience. So we just need to
So
go through this video and step. That's it. That is fine to crack any
cluster
checkpoint interview.
cluster Excel just like a HA and load
Yeah,
sharing.
correct.
And what is the core Excel and secure Excel?
Yeah, we'll cover that in details. Core
Okay.
Excel, I think I have given some little bit overview on our first or second sessions. Core Excel is the acceleration feature in checkpoint. So if traffic come into the checkpoint, it is come to the SND. SND is the master, and SND is going to assign the traffic to the multiple CPU. So it is going to be distribute load balance the traffic amongst multiple CPU. So
Okay.
that is the called core Excel. So if anyone
Okay.
asks interview, so core Excel is the acceleration features. It is used to distribute traffic among multiple CPU. Multiple CPU can handle multiple traffic, and all are independent to each other. So this is the definition of core Excel. And sometimes they ask what is the command to check core Excel. AFWCTL multi-stack. AFWCTL multi means core Excel. AFWCTL multi-state, STATT. That's it.
And
So we'll
secure Excel?
see. Secure Excel is also the we can say like acceleration features. In core Excel, we can say it is performance enhanced technology. In secure Excel, it is acceleration technology. So if traffic come into the firewall and if the entry in the secure Excel connection table, it is going to be directly sent to the outside interface. It is not going to be follow the check operating system process like security policy check, NAT check, routing check. No. If traffic come into the firewall, if we enter in secure Excel connection table, it is directly sent to the outside interface. But yes, not every new packet in the secure Excel connection tables. So if 10 traffic come to the firewall, only 1/4 is going to be stored in secure Excel. For example, out of 10, 4 packet is going to be stored in secure Excel, but not new packet. Just remember it. New packet is always follow the all the process like security policy, NAT, routing, everything. So if any old packet coming and entering secure Excel, it is going to be escalate.
Okay,
So it is a escalation features.
Okay, secure Excel just like a stateful firewall. They are storing the state session just like that.
Yeah, secure Excel is similar like our normal connection table. Secure Excel connection table is similar to connection tables, normal connection tables, but a 1/4 connection is stored in secure Excel. So this is how designed to provide better speed related to traffic. Okay. For example, if every packet is going to be handled through operating system level like CPU with the help of CPU like security policy, routing, NAT, everything, maybe we can see some slowness, right? But if entry is already in secure Excel and already packet is checked, so if same packet coming to the firewall, it is going to be sent to the outside. And while doing that, performance will be increased, speed will be increased. So this is about secure Excel. Secure Excel is escalation features and core Excel is performance enhanced technology. So we'll see in details, no problem. We'll see in details, we'll see some debug commands, like how we can debug core Excel, how we can debug secure Excel, how we can debug cluster Excel. We'll see all in the details.
Okay.
Yeah. But yeah, these are the importance. Okay, so I think Saji has to join another call and we just need to copy both like deployment agent image in both the firewalls, Saji. And after that, we just need to keep as it is. And once we connect, then we'll move ahead for the upgrade.
Yeah. I'll start on the firewalls, like building the VPN.
Yeah, make the topology ready. Just do management configurations.
Yep.
And VPN configuration will do live.
Yep.
We just need to do management configuration. Try to take firewall off, and after management, rest of the configuration related to VPN we can do on the training session.
Okay, sounds good.
Just do the management configuration, not VPN related.
Yeah, definitely. Just as long as you do it.
Yeah, and copy both the image, like image and deployment agent, both the firewall /home admin directory. And once we connect, we'll move this to the CPU's repository, and then we'll upgrade our box one by one.
Okay. And if the week is quiet, I'll let you know. Maybe we can all meet again, maybe during the week. If not, we'll do on the weekend.
Yeah. I will try to get some time, like 1.5 an hour at least, and we'll complete our upgrade part.
Okay.